Okay, here we're going to be talking about phase diagrams, and they basically show the transitions between all the different phases. Now I'm going to write the phase diagram on the board, and this type of diagram is exactly the type of diagram that I'd like you to be able to reproduce as well. So you have to know the different parts of it, you have to know how to label the axes, and how to actually draw it and draw the important points on the graph. So let's start by just drawing our axes. Okay, there are our axes. When I say label the axes, I'm not saying tell me which is X and which is Y. What I'm telling you is to tell me what they represent. So down here we're going to have temperature, and up here we're going to have pressure. That's what I mean by labeling the axes. Now, all phase diagrams have a similar shape. It doesn't matter what the compound happens to be, it's going to be this Y shape. And you can see on the slides, it's a little cleaner on the slides as to what the shape of this guy is, but I'm going to expect you to be able to redraw this, so this is my drawing of it. Over here, any combination of pressure and temperature that puts you in this area here is going to be in solid phase. If you have a pressure and a temperature and it puts you in this Y area here, you're going to be in liquid phase. And any combination of the pressure and the temperature that puts you in this area over here is going to be the gas phase. Okay? So from this diagram, you can take the pressure and the temperature of any particular condition, have them meet up, and you can tell which state of matter that substance happens to be at. There are a few points that are very important on this line that you should be able to label. This one right here is called the triple point. It is important because it's the one pressure and temperature that all three states of matter are in equilibrium at. So we have solid, liquid, and gas at that particular pressure and temperature. This line here, when you go from a solid to a liquid, or a liquid to a solid, that's our freezing point, right? So this is the freezing point line. Liquid and gas, that transition is called the boiling point. So this is the boiling point line. If you want the boiling point at a particular pressure, you just look at the pressure, come over to the boiling point line, go down, and you can find the temperature at which that boiling point happens to be. And of course, your transition between your solid and your gas, it's sublimation. So this is the sublimation point line. Now there is a very special horizontal line on this, and that is at 1 atmosphere. Or if you're labeling it in millimeters of mercury, it'd be 760 millimeters of mercury. Remember, that is our standard pressure. So the freezing point at 1 atmosphere, we had a special name for. This was known as the normal freezing point. And the boiling point at 1 atmosphere was called the normal boiling point. So I want you to be able to draw this diagram, label it as I did here, and also don't forget, if you're asked to show me the normal boiling point and the normal freezing point, you better have this line there, and it better be labeled what that line means 1 atmosphere, 760 millimeters of mercury. Okay, don't forget that. That's the point where a lot of students lose a little bit of credit because they don't tell me what that line is, what that line really means. Okay. Now, let's look at an example. Most of them, like water, is the one that we have on our slides. Water will have a certain set of numbers that goes along with the pressure and the temperature. The numbers will change from one compound to another compound, but the shape does not. Okay, the general shape does not. So the first slide is of water. The second slide is of carbon dioxide. And here I've reproduced the one with carbon dioxide. You can see it's the Y shape. And the thing I want to point out for carbon dioxide is where the 1 atmosphere is. Remember, for most substances, the 1 atmosphere will be somewhere up here, and you've got all 3 stages. You've got your solid, your liquid, and your gas. But there's something very interesting that occurs with carbon dioxide. Remember, this is CO2. This is your 1 atmosphere for CO2. At 1 atmosphere, that's where we live, you can see that there's a solid phase and there's a gas phase. There is no liquid phase. Right? That's why dry ice goes through sublimation and deposition, because it doesn't have a liquid phase at 1 atmosphere. You have to get all the way up to 5 atmospheres in order to even see liquid. So that's a really, really high pressure. It's 5 times the pressure of our normal atmosphere. So these types of phase diagrams can explain why things behave the way they do. This is why we don't see a liquid phase for carbon dioxide.